Alrighty, so we have our video on graphing absolute value functions. And an absolute value function is just another type of linear function. And the parent function for an absolute value function is just simply take the absolute value of whatever you plug into it, and that's your function value, that's your f of x. A couple things about our absolute value functions: they are V-shaped. You can put any number in there you want to. However, in absence to absolute value, what it does is make it something positive. Then your range should be any number except for negatives. You can't have negatives for your y values, for your function values. Now, the other thing that my class looked at was transformations, and I'm just going to kind of put these up here for you because you're just going to have these and refer back to them. This is the general form of everything possible that you could have in an absolute value equation. You could have an A, an H, and a K. And there's a couple things about this. If this H, let's go with K first. I have the rules here. If K is greater than 0, it's transformed by sliding up that many units. If it's less than 0, so if it's negative, you go down that many units. H, if that H is greater than 0, so you're going to have a minus here still, then you go right that many units. Let me get my other notes. If that H is less than 0, then you have a minus negative, in which creates a plus there, and so you would slide left however many units H is. Now, the dilations and reflections. If this A, so if that coefficient of X, whether it's on the outside of the absolute value or on the inside, is negative, then that means you have a reflection over the X-axis. If that A, doesn't matter if it's inside the absolute value or outside the absolute value, is greater than 1, you have a vertical stretch. If it's in between 0 and 1, you have a vertical compression. So those are just some key terms that we're going to have to answer in our questions today. Alright, so my students' homework look like this. Okay, and so, get my pencil here. Let's see, which one? I'm going to do 13, but let's look at, well, let's just take, the first one was number 1, and we know that this is going to be just translated up 1 unit. Number 5 is translated to the right 3 units. Number 7 is going to be that reflection piece reflected across the X. Number 8, and they had number 10. So let's just look at number 8 just to show you how to plug in. Well, I might just do number 13 because it's going to show you everything. So just all of these you would do just like number 13, okay? The way that I'm going to do it, I'm going to create a table, plug in my values. Let's just do number 8 because that way you can see what we're looking at here. Okay, so the first thing that you do in order to graph an equation, there's my pencils over here, is you make a table of values. So you have an X, you put your function rule, which is 3, absolute value of X, and then this equals g of x. Now, the values I told my students to choose today were -2, -1, 0, 1, and 2. But your graph needs to make a V all the time. So if you were to choose these points and you didn't form a V, you would need to go either more negative or more positive to get that V to appear. Plugging it in, 3 times the absolute value of -2. This absolute value of -2 makes this a positive 2. 3 times 2 is 6. 3 times the absolute value of -1 is 3 times 1, which is 3. 3 times the absolute value of 0, of course, is 0. 3 times the absolute value of 1 is 3. 3 times the absolute value of 2 is 6. So, when I go to graph these, then I have my graph here. I simply do left 2 up 1, 2, 3, 4, 5, 6. Left 1 up 1, 2, 3. 0, 0. Over 1 up 3. And over 2 up 6. So you can tell, well, I'll show you the graph of the parent function, just a plain old X that I did with my students. This is the graph of just the parent function. Okay, and so you can see that the difference in the two graphs, they both still have a vertex, that's the origin, but this one is much skinnier than the other. And so going back to our transformation rules, if that number is greater than 1, then we say there was a vertical stretch. It was like we stretched it up and made it skinnier. So for our transformation, we would say that we have a vertical stretch by a factor of 3. And for the domain, it will be all real, okay? But for the range, it's going to be all real, but you cannot have anything below this 0 point. So it's going to be 0 and up. So all real greater than or equal to 0, okay? The only ones where you really have a range different than greater than or equal to 0 are ones that have +1 on the outside of the parentheses or -1 on the outside, because that's going to move it up or down, and that's going to change your range, but nothing else will change your range. It will be greater than or equal to 0. All right, let's look at how this would be related to a word problem, a real life problem. The function f of x, and I'm just reading from number 13, f of x equals -1/2 absolute value of x minus 16, close absolute value plus 20, but our domain is specified this time. Okay, you can only have values 0 to 32 because this models the shape of a house roof, where f of x is the height of the roof at a horizontal distance of x feet from the left end of the roof. So you can't have a negative distance. So it has to be 0 to 32. Graph it and decide what is that highest peak of the roof. It says what is the peak, but that's going to be what is your highest value before your v star should come back down. Okay, so when I go to choose x values for this, put my function here, -1/2 x minus 16 plus 20, have my f of x. I need to go get some values from 0 to 32 that would give a good range here. So let's do 0, 10, well, I could actually do count by 5s maybe. 0, 5, 10, 15, 20, 25, 30. Okay? Okay, so plugging in these values, -1/2, 0 minus 16 plus 20, -1/2, 5 minus 16 plus 20, okay? -1/2, 10 minus 16 plus 20, -1/2, 15 minus 16 plus 20, -1/2, 20 minus 16 plus 20. I'm going to stop there and see if that gets us what we need. If it gets us our peak, we'll have to see. Alright, so 0 minus 16 is -16. Make it positive 16. But you multiply it by -1/2, so that's a -8. 20 minus 8 is 12. Okay? 5 minus 16 is going to be -11. Alright, make it positive. So half of -11 is -5.5, and 20 minus 5.5 would be 14.5. Okay? We got -6, make it a positive, so -half of 6 is -3 plus 20 would be a positive 17. 15 minus 16 is -1, half of that would be -5, so 19.5. 20 minus 16 would be 4, times -1/2 would be -2, so 20 minus, okay, what am I? Okay, so you got -14 and then, yeah, so it would be 18. So we can see here we've hit our peak and we're going to start to come back down. So we've hit close to our peak. So if we want, when we can graph these points, but if we want to see exactly, so let's go ahead and graph our points here. Okay, we hit our peak somewhere between 15 and 20. So let's go ahead and plot our points. Alright, so we have to go, the highest we have to go is to this 19.5, okay, or somewhere, so let's count by 2s, and we'll go from 2 to 20. Okay, now, let's get what we have. We have 0, 12, and then we have, and we're going to count by 5s here, 5, 10, 15, 20, 25, and 30. Okay, so 5 is 14.5, 10 is 17, 15 is 19.5,